In this video, we're going to look at an example of approximating a sum of a series within a certain tolerance. So we're being asked to find the sum of the series n equals 1 to infinity of 1 over n to the fifth, correct to 3 decimal places. And the way I'm going to interpret correct to 3 decimal places means that we want it correct to within 0.001. Now some other books might say you want to be less than 0.0005 to make sure that you don't have any rounding issues as well. I'm going to just simplify it and make it less than 0.0001 or 0.001 just to make it easier and not have to worry about if I need a half of that or what have you. So anyway, in order to make this happen, we want to make sure that a remainder that occurs by using the first n terms of the series is less than 0.001. From what we know that the remainder from the integral test, if we know the remainder is going to be less than or equal to the piece of the area, if you will, that's under the function 1 over x to the fifth, because the series here is 1 over n to the fifth. The remainder will be less than that integral from n to infinity of that function. So the area that's under the function from n to infinity will contain the areas that would go from adding up the n plus first term, the n plus second term, the n plus third term, and so on. All of those, if you think about them as rectangles, all of those rectangles would be included in that area. So the remainder that occurs by leaving those terms off must be less than or equal to that improper integral. So now we just have an inequality to solve. We want that improper integral to be less than 0.001. Handle our improper limit of integration like we always do, using a limit. Find an antiderivative. Plug in our endpoints. Now in this case, I've switched things around. Usually we think about plugging in b and then subtracting when we plug in what we get when we plug in n. Of course, we get minus a minus there, which makes that positive. So I just flip the order around. All right, so now as b goes to infinity, the second term here goes to 0. So the limit turns out to just be 1 over 4 to the n plus 4. We still want that less than 0.001. Moving this around and solving for n, we get that n needs to be greater than the fourth root of 1 over 0.004, which is around 3.98. So since n has to be an integer here, we need n to be at least 4. So if we use the first 4 terms of the series, we should get something correct at 3 decimal places or within that 0.001 tolerance. So put in 1, put in 2, put in 3, put in 4. So we get 1 plus 1/32 plus 1 243rd plus 1 1024th and get it something that's approximately 1.036. That'll give us an approximation of that sum of that series.